Hi students, welcome to the problem solving session on periodic signal in discrete time domain. Right? So let us see these questions. Right? Check whether the following signals are periodic. If yes, find fundamental period. So what is the first question? First question is x of n is equal to 3 cos 4 pi n plus 2 sin pi n. Right? So when this is a composite signal, right? This signal is composed of two signals, right? So x1 of n and x2 of n, right? So first we have to check in order to find the periodicity of x of n. We have to ensure that this is periodic, then this is also periodic, then only the signal x of n is periodic, right? In continuous time signal, we don't mind about that. What we do is we find a t1 and a t2. If t1 by t2 is rational, we will say it is periodic. But here that is not the case. In discrete time domain, we have to check, we have to ensure that this is periodic. If this is not periodic, total signal is aperiodic, right? And we have to ensure this is also periodic. Then only we can, then we have to see that n1 by n2, let us assume this is a period of n1, this is a period of n2, then we have to find n1 by n2. That must be rational number. So three condition must be tested. First, check this is periodic, next check this is periodic, then the ratio of the period must be rational number, then only it is periodic signal, right? Let us see. So take this one. So what is n1 period of this signal? We know that period is given by 2 pi by omega naught. Omega naught is here 4 pi. So 4 pi into m, that is 1 by 2m. When you substitute m is equal to 2, n1 will become 1 when m is equal to 2. So it is an integer. N is integer, m is integer, so it is periodic with the fundamental period 1. For this, we go to n2, 2 pi by omega. Omega is nothing but pi into m. So pi cancel. So n2 is equal to 2. When you substitute m is equal to 1 itself, we will get integer value. So n is integer, m is integer, so it is a periodic signal with the period 2. Now we can go and check that n1 by n2, whether n1 by n2, n1 by n2 is ratio of integer 1 by 2, so it is periodic. Our signal is periodic signal. Now we have to find the fundamental period of x of n. How to find? That can be obtained by taking LCM of, let us assume n is a period of x of n. That is obtained by taking LCM of both the signal, right? n1 comma n2, period of those signals. So LCM of n1 is 1, LCM of 2, LCM of 1 comma 2 is 2. That is what the fundamental period of the given signal x of n. So the signal has fundamental period of 2. See, what is the meaning? We got n1 is 1. We got n2 is 2. See, what it indicates? This signal repeats for every one sample. This signal repeats for every two samples. Then when the collectively they will repeat. For example, first signal repeats every one sample. Second signal repeats every two samples. The common signal repeats at every two samples. Then this will repeat at 4. It will repeat at 1, 2, 3, 4. Again, where they will meet at 2 they will meet. They will change. They will change. At 4 only again they will change. Yes or no? Together. That's what the common period. Are you understanding the logic? So n is equal to 2 is a period of the signal. Okay, common signal x of n. Now next question is e power j pi by 3, e power j 5 pi. Right. So second question is x of n is equal to e power j pi by 3 n plus e power j 5 pi n. Same logic, right? First we have to find n1. n1 is equal to 2 pi by omega. This is what my omega. So pi by 3 m. This indicates pi cancel 6m. So m is equal to 1 indicates n1 becomes 6. So it is a integer. M is also integer. M is integer that we have to choose. right? So n is integer, so it is a periodic. This one is periodic. Next we have to find n2 value 2 pi by 5 pi because omega is 5 pi. This one, right, into m, pi by cancel. So this indicates n2 is equal to 2 and m is equal to 5. We substitute m is equal to 5, n becomes integer. So m is integer, n is integer. So second signal is also periodic. Right, now we have to check whether x of n is periodic or not. Go for n1 by n2. Right, so n1 by n2 is ratio of integer. Clear or not? So it is 2 by 1 by 5. It is a ratio of integer rational number. This implies x of n is periodic. Yes or no? What is the fundamental period? We have to find the fundamental period of that signal. That is given by LCM of 6, 2. What is the LCM of 6, 2? 6. So x of n is periodic with the fundamental period n is equal to 6. Simple problem. Okay. So third problem, what is the third problem they are talking? Third problem is sin pi n plus sin 2n. So you see sin pi n, I do here. So n1 is equal to 2 pi by omega is pi here into m. So pi cancel. When you substitute m is equal to 1, right? When you substitute m is equal to 1, n becomes 2. So n1 is equal to 2, m is equal to 1. So this is periodic. What about n2? n2 is 2 pi by omega is 2. 2 into m pi. So whatever be the value of m you substitute in the integer value, n will not become integer because it is multiplied by rational number, irrational number pi. So n2 will not be becoming integer. So it is aperiodic signal. So this is aperiodic. So periodic plus aperiodic, surely it will be aperiodic only. No need to check. Okay. Fourth one, you see 2u of n. U of n is a unit step. Surely it is aperiodic. Aperiodic plus periodic, it will be a aperiodic only. So anyway, you check this 3 sin 2n. 3 sin 2n. We see 3 sin 2n. If you put 3 sin 2n, what is n? N is equal to 2 pi by omega. Omega is equal to 2 m. So pi m, it will never become integer. N will not become integer. So both are aperiodic only. So the result is also aperiodic. This is aperiodic. This is aperiodic. So the resultant signal is aperiodic. Next one is e power j 2 pi n, e power j 2n. Right. So last problem, e power j 2 pi n plus e power j 2n. Right. This is a beautiful problem. First we see what is the question? Our n1 is 2 pi by omega. What is our omega here? Omega is 2 pi. 2 pi into m. So for m is equal to 1, we get n1 is equal to 1. For m is equal to 1. So m is integer that we choose. N is also integer. Surely it is periodic. This one is periodic. Next we check this. E power j 2n. N is equal to 2 pi by omega is 2. So 2 pi by 2m. And pi. Surely it never become integer for any m value. So this is aperiodic. This is periodic. This is aperiodic. So x of n is surely aperiodic. Periodic plus aperiodic will be aperiodic only. So my answer is aperiodic. This is aperiodic. Okay. So first problem, we know it is periodic. This is also periodic. Right. I hope you understand the concept. If you have any doubt, please ask me in comment section. Thank you.